So, ladies and gentlemen, when doing a problem like this, all right, when working a problem like this, what we're simply going to do is there's a couple things I want you guys to identify. All right, obviously they're asking us to find the sine of theta, and I know all of you have been inside of geometry, so you should be familiar with at least looking at right triangles. You might have already forgot trigonometry, but hopefully you still remember working with right triangles. So when we're applying trig, we got to make sure that our triangle is a right triangle, right? And we can determine it's a right triangle based on this angle right here that tells us it's a right triangle, all right? So when we have a right triangle, again, we can apply the Pythagorean theorem, and we can also use our trigonometry, all right? The best way that I would say to remember our trig was what we called our SOHCAHTOA. And if you do not remember trig from geometry or another class that you took that involved trig, I would highly recommend you write that down, because throughout the regular tests that you guys have, you are going to want to remember all the different trig ratios. So what SOHCAHTOA helps us remember is that the sine of an angle is equal to the ratio of opposite over hypotenuse. The cosine of an angle is equal to the ratio of the adjacent side over the hypotenuse. And the tangent of an angle is equal to the ratio of the opposite side over the adjacent side. All right? So when we have our trigonometric ratio, our trigonometric functions, the trigonometric function of an angle, what they represent is ratios of sides of a triangle. So what we need to do then is identify, well, what is the adjacent, opposite, and hypotenuse? And this can sometimes be difficult because it all depends on what angle you're referring to. So let me give you an example. Sorry, thank you. So ladies and gentlemen, there's two triangles, all right? And let's say I want to refer to two different angles, all right? What I want to do is make sure you guys understand how to identify the adjacent, the hypotenuse, and the opposite, because this is mostly where students make the mistakes. Usually they can kind of remember what the ratio is, but they make the mistake which is identifying which each side was. I think the easiest to identify is the hypotenuse. Most students remember the hypotenuse from the Pythagorean theorem. When you have a right triangle, the hypotenuse is your longest side, right? Yes. And it always is directly across from the 90-degree angle. Sometimes I draw an arrow from that 90-degree angle to remember that. It's always directly across from the 90-degree angle, and it's your largest side. Now, the next definition that I like to describe is what we call the adjacent side. And the adjacent side is the leg that connects your right angle and the angle that you're using for your ratio. Connects the right angle and the angle that you're using for your ratio. So do you guys see for each of these triangles, here is my adjacent side, but now when I refer to this angle, now that's the adjacent side? Does that kind of make sense how it can change depending on what angle you're referring to? Yes. OK. Then the next thing is, if it's not the hypotenuse adjacent, then it's your opposite side. OK? So in this example, basically what we want to do is identify. So we're trying to find the sine of an angle, right? So we have theta or alpha. We're obviously going to be using this angle, right? So here is the angle we're referring to. So when we're referring to this angle, basically it's going to look something like this. So therefore we can say, for sine, we want to find the ratio of the opposite side over the hypotenuse. So the opposite of theta is going to be 12 inches. Over 13 inches, which reduces down to 13 over 12, or I'm sorry, yeah, 12 over 13, which is answer number C. OK?
Answer number C.
Or answer letter C. Anybody have any other questions on that?